It wasn't necessarily any one bit of kit or any bit of equipment. It was really the knowledge and experience we have in working with graphene for all of these years that meant that we could apply that to this project to then get the best outcomes as quickly as possible.
Mark 1.
The CEAMS project is a collaboration between an industry partner, Levidian, the National Physical Laboratory, NPL, and the Henry Royce Institute, working on developing new battery materials. So Levidian make graphene, amongst other things, and they were supplying graphene to us here at the Royce, where we were formulating it, putting it into batteries, assembling them, testing them, and then sending them to NPL, who was independently doing those battery testing to find out which of these new materials that Levidian were developing would work best in these new generation of batteries. A lot of the equipment that we have here wasn't particularly novel or wasn't particularly different than you'd have in a lot of other labs, but we've had many, many years of working with graphene, particularly for electrochemical energy storage like batteries. And so it's really those years of experience that meant that we could formulate it, make these batteries the correct way in a short period of time, and really understand which of these new materials that Levidian were providing us was going to give us the best benefit in these new batteries that we were making.
You go what?
Levidian is a British climate tech company, and we mainly do three things. We decarbonize businesses, we produce hydrogen, and we also produce graphene. Yeah, this project is about the development of graphene batteries. However, this project was aiming to explore more advanced technologies. These are new chemistry that basically more sustainable than the current technology that are used today, because current technologies that are based on cobalt and nickel, all with high carbon emissions. Within this project, we managed to explore and understand if our graphene works in this new advanced battery chemistry.
So in addition to the graphene powder, the other valuable forms that we provide are dispersions such as these, which are used in battery electrodes on anode and cathode side. And in fact, these are the same ones that were used in this project.
The collaboration was actually very strong. We produced all the materials, and then all our materials were processed by Manchester, and then these batteries were then characterized by NPL.
Yeah, 1.
We have Levidian, of course, Manchester University working on some preparation of material, and our role at NPL is to measure the batteries or the cells that are made in the Manchester University, and we measure with our calibrating instrument at NPL, and we report all the results to Levidian. In particular, this project, we were looking at new battery chemistries that were different from what's commercially available. So not just a simple lithium-ion battery, but new chemistries. And one of the things with those is that they're not currently out there in the market because of these issues with lifetime, with cycle stability. So by being able to make these last longer and being able to make them higher capacity, we do make them sort of more commercially appealing and make them more interesting. The idea being that Levidian can sell this material to battery manufacturers and suppliers who can then actually start to introduce it to the market so it has real-world impact.